morning, everybody, again from my side. I hope you have a wonderful day. We have some rain here in Switzerland today, but nevertheless, I hope we'll have a very fruitful talk and discussion today. As Miriam already introduced, my name is Maximilian Eichberger. I will quickly introduce myself on the next slide, and then we'll see the topics of the talk. The talk will last for about 1 hour. And I hope you will have a very interactive discussion on it. Feel free to ask questions. I just can't mention that enough, because I think it's very good to address the points that are at your interest. So I'm currently working as a product manager for humidity and temperature sensors with Sensirion. I finished a diploma in physics and a PhD in physics, both at the University of Constance in Germany, and now I'm at my first year with Sensirion. So, well, it's a young company and it's young employees. Okay, I can't, once again, please feel free to ask questions. I will have a certain block or time after each chapter to address those questions. Miriam will read them out loudly so that everybody can get a grip on the question and the information, and I will try to answer after each block so that the discussion is still fresh. So a few words on my talk now. I give a short introduction to the company, and then I will focus on the physics of humidity and how we are going to sense that and what is important for sensing humidity seriously, and then I'll also introduce how we do it at Sensirion with our latest SHT3X products, which are designed for measuring humidity and temperature at a very high, accurate and reliable level. Finally, I will propose some design guidance and handling instructions so that you can use our sensors properly. Finishing will be a summary of the talk. So the company information is just a quick overview. We are still a young company, as I mentioned. We are not 20 years yet. Our headquarters are in Switzerland, just like 20 kilometers south of Zurich. It's Stäfa. It's still the greater area of Zurich. We have a very steep growth at the moment, not only in turnover, but at the moment we are employing 600 people here in Stäfa, in the headquarters, where also a large R&D and production facility is based. I will quickly also address the point that our CMOSense technology puts a great advantage in how to measure humidity and temperature with very small footprint sensors. And what you can see here is the latest turnover. So we are a medium-sized company with about 130, 140 million Swiss francs turnover, and on the right side you see the founders of the company, which is Moritz Lechner and Felix Meyer, and they're still CEOs, co-CEOs, and the company is still privately owned. So we have a very long-term perspective on what we want to do research-wise and what we want to do product-wise, and that's actually a quite good working environment too. Our product groups are not only humidity and temperature sensors, which the talk will be about, but it's also flow sensors, differential pressure sensors, flow sensors for the gas and the liquid state, and customer-specific solutions and so on. So there's quite a matrix of different products which we are developing and working on. So I will focus now on the humidity sensors, which is intrinsically also having a temperature sensor too. What we did is miniaturizing the sensing element and the readout electronics, and we call this the CMOSense technology. And we have the RH sensor here and the temperature sensor and all the electronics. And analog digital converters and so on a 1-1 chip, and that allows you to produce a very small DFM packaged sensor, which was the second generation, the SHT2X, which is at the moment the highest volume product which we are currently producing. And from there we went on and made even smaller sensors, which are the SHT C1 and W1, which is finally just a chip scale package. So the whole sensor is as small as a single die. And the next generation, the SHT3X, which we are launching, or which we have launched already this year, is a very versatile sensor, which I address in the following slides. What the versatility of the sensor actually means. But now let's just quickly go into the topic of discussing the physics of humidity. But let me quickly check back with Miriam. Are there any questions so far? Can you hear me well?
Hi Max. So far we don't have any questions regarding presentation.
And there are no complaints about not hearing me properly?
No.
Excellent. Okay, then I'll continue. Thanks a lot.
Okay, thank you.
So let's go to the physics of humidity. What's humidity actually? It's just water in the gaseous state, so to speak, and the air has a certain ability to accommodate a certain amount of gaseous water, because if the water gas pressure is too high, it will just condensate, and it's not vaporous anymore. So there's a certain maximum amount of gaseous water which is acceptable to the air. So if you have a closed box now, a closed environment, we will have an equilibrium state where the evaporation rate from the liquid phase into the gas phase, it will be equal to the condensation rate from the gas phase to the liquid state. And in this state, the air is saturated with water vapor, and this is the maximum amount of water vapor the air can accommodate. So what's happening if we increase the temperature? If we increase the temperature, more water is released from the liquid state into the gas state, and the air also can accommodate more gaseous water. So there's more water vapor saturated in the air. This is following an exponential law. So the saturation vapor pressure of gaseous water is an exponential law with respect to temperature. And like I already mentioned, we have an equilibrium state once the evaporation rate and the condensation rate are equal. And again, we see that this exponential law will be a phase limit line between the gaseous state and the liquid state. So if you are, for an example, if you have a temperature of 30 degrees Celsius and we have a relative humidity of 50%, then there is this is actually the amount of water vapor in the air divided by the maximum possible water vapor in the air. So if you double the amount of water vapor in the air, then you will reach this line, and then you will cross from the gaseous state to the liquid state. And so you will have different exponential lines for certain values of relative humidity, and so you already can see that it's very important if you talk about relative humidity at which temperature you are sitting. So for example, if you're sitting at 40 degrees Celsius, your relative humidity of 50% means that you can have a lot of more water vapor in the air. There's a different description of relative humidity. That's the dew point, which is basically the temperature. It's a temperature value which is derived from your certain relative humidity value, and if you're going horizontally towards the phase transition line, which is the green line that I already introduced. So, and once you're hitting that line, that means you would be crossing the transition from the gas state to the liquid state. And this is the dew point. So if you have a certain humidity at that room temperature, or at a temperature of 30 degrees Celsius, for example, the dew point would in this case be 18 degrees Celsius. And if you shock cool the room or the environment down to 18 degrees Celsius, your water vapor will start to condensate. So what's the main topics I wanted to share with you here is that humidity is a relevant topic to our everyday life. So we are always exposed to humid air, unless, I mean, you experience that in heated rooms in winter when there's lots of heating power, and the dry, cool air will be heated up, and you will have breathing issues if the air is too dry. So it's a very important factor for our well-being, and humidity is basically the gaseous water, or the gas phase of water in airs. And we have different definitions, which is the relative humidity or the dew point to describe a certain humidity state. And once again, it's very important to have the temperature if you're talking about relative humidity, and this is why I've already mentioned that every RH sensor, relative humidity sensor, also intrinsically has a temperature sensor. So this is basically a short introduction into the relative humidity topic. Miriam, are there any questions so far?
So far we don't have any questions, so we can continue.
Okay, thank you very much.
Thank you.
Let's talk about what we are doing to detect humidity at Sensirion. We have quite a large variety of products, and they are all based on the patented technology which we call ChemoSense. And this means that if we are here at the bottom, you see our latest BFN package-sized SHT3X humidity sensor, and if you look closer, you see a hole in the middle, and the hole in the package is basically directly opening the package to the die, and the silicon die is in this case covered with some electronic structures, which you see here at the bottom in form of a grid structure, and on top of it there's a polymer. And what happens if this polymer, it's a certain polymer, it's a water accepting polymer, so if there's a high humidity or if there's a large number of H2O molecules in the air, then these water molecules will penetrate into the polymer and change its capacitance. So what we are actually doing is measuring the capacitance of this capacitor, which consists of this grid structure and the polymer, and we do this with a frequency measurement, and you can measure it very, very accurately. And the absorption of the water molecules into the polymer compound is a reversible process. So if you are, after having a high humidity environment, putting the sensor in a very dry air, the evaporation rate of the water molecules out of the polymer will be high until there's an equilibrium reached. So, and since this is everything very, very small and compact, we have a very high response rate. So it's a very instantaneous process of measuring humidity if you look into previous very large sensor technologies. So this is the response time benefits strongly from a very small electronics and from a very small sensor element. So to keep it short, what's happening here underneath the package, you will only see here the sensor opening. We will here have an RH sensor and a T sensor. The RH sensor, which is depicted here schematically, is sitting here on the die, and this will be exposed to the outer environment through this hole here. And this is in principle, together with all the data processing and the supply voltage and the signal, this is the basis or the foundation for this very small scale sensor technology. And this is what we use for all of our sensors, and which we are our humidity sensors, and this is what we have over 20 years of experience since the founders already did their PhD work on this topic. And this is what we are constantly working on and improving and trying to get even better and more reliable with this sort of approach to the humidity measurement. So let me now go a little bit more into the detail of this our most current product, which is the SHT3X, where we condensed all our experience so far in humidity sensing, and we have here the X basically is a discriminator for the accuracy class. So what we will have here is a base version, which is a price optimized version of the SHT30, which has a digital and an analog output, and this is the article description, which is a digital interface I2C interface, and this is an analog ratiometric output in brackets. These are the ordering amounts, but this is not of real interest now for the moment. And we have three accuracy classes. The second one is the SHT31, which has also a digital and analog output, but more analog outputs offers more analog outputs than the 30. And finally, we have a very high demand product, which is the 35, which only comes as a digital version. And as a further speciality of this product, we also tried to make life easier for the application engineers or for the production engineers. So we offer the sensor now with a membrane which is sitting on top of the sensor opening. So this is here, it's pretty much like what you know from your Gore-Tex outdoor jacket. It's a PTFE membrane which will keep dust and water droplets and dirt and oil. It's also oleophobic contaminations away from the sensor opening, and it makes it more reliable. And we also offer a polyimide cover, which is in principle a Kapton cover, which is on top of the sensor to protect the opening, and you can reflow solder the sensor with this polyimide cover, and after everything is mounted, you can use some protective spray or coating for the electronics, and then you just pull off the cover, and the sensor, you don't really need to be afraid that you will accidentally cover the sensor opening with some coatings which you apply for the electronics. So the sensor looks like, in more detail, it looks like this. It has an 8-pin DFN package, and it's size-wise it's thinner than a millimeter and has 2.5 millimeters edge size, and it's also always marked with the name. And here's the DI is basically the digital interface I2C, and this is an alphanumeric code to enable tracking on Sensirion side, and also there's a laser marked point which allows you to identify the pin orders. So what's now the advantage of this product, or where did we evolve from previous products? What's our learning curve on this SHT3X? So it's always an interesting question, how accurately can you detect temperature and humidity, of course. And where we've been so far was that we have a typical delta RH for the whole humidity range, which was in the order of plus minus 2%, and we were able now to flatten this accuracy level, and also the maximum values are like almost flat, and we could significantly reduce the maximum accuracy of the delta RH. Maximum accuracy means a deviation of force sigma of a set of sensors. But there's also a little more detail, because we have a two-dimensional phase space, if you wish. We have temperature and we have relative humidity. And if you look at the whole two-dimensional accuracy map, you will see that there are quite some edges and side points where the sensor is not that homogeneous as you wish it to be. And here, if you look into, this is the previous sensor. I should have explicitly or labeled it. It's the previous sensor. It's the SHT21, and the SHT31 now really changed this whole accuracy map into ±2%. So you, as an application engineer, don't really need to worry about, okay, what's my temperature and relative humidity now to look it up, if how accurate is my measurement. Actually, it's everywhere it's ±2%. Okay, so let me briefly discuss the analog outputs. We have a ratiometric voltage output of 10 to 90% of the supply voltage. It's a fully calibrated signal. What we do is we have the analog signal converted into a digital one, linearize it, and do back the analog conversion. And this is our output. So the output, this is the ratiometric output, independently of the humidity ranging from 0 to 100% humidity. And you can read out the temperature and the RH value on two different pins here. So it's pin 1 is for the RH, and pin 4 is for the temperature. And what you can see here is a side note, you see this spot here is the laser marking, which I mentioned in the beginning. So go back a few slides, you can see here this is the laser marking. So this always allows you to uniquely identify your sensor pins. So let's go back to this slide. A second feature which we now have implemented on the sensor is an alert value that you can set independently for the RH and the temperature values. So as soon as the for example, the temperature or the humidity rises above a high set value, then the sensor will communicate the new RH value, and unless this is not happening, the sensor will just not communicate, and in this case start or save on power. And you can set different high values and clear values, and also can set low clear and low set values. And what I would like to quickly also introduce to you now is that the sensor is basically this small 2.5 millimeter square package, and it's very hard to get a grip on it once you just have the sensor lying around. And Miriama will mention this probably later also, and that we will provide a small Bluetooth gadget, which we call it, which has the sensor, the current sensor implemented, and it comes with a battery you see here, and a Bluetooth module and a display, and it's quite a handy small temperature and RH weather station, if you wish. Without weather station would mean you have a pressure tube, but this is not the case. So I will just call it an advanced thermostat. And what's the nice feature about it, that you can download an app in the Apple Store or in the Play Store for Android smartphones, and can communicate with the gadget via Bluetooth, and this will allow you to log your temperature and humidity values over time, and this will also give you a first grip on the sensor itself. So you have a smartphone connectivity, and there's also an app which you can download for free in your relevant Play Store, and you can just get started with unmoving the protective cover for the battery, and then it's pretty much self-explaining, but we will also have a data sheet coming with the gadget. So feel free to use it, and please enjoy the app. So what we will offer for engineering applications are the evaluation kits. Miriam already mentioned in the beginning, we will have a special offer on the H5 version for today. So this is a very simple plug-and-play solution for your computer. You can use it with a USB adapter, and at the end of the cable you have different options to mount different sensors. So it comes with several sensors, and I will quickly show you once you've downloaded the software. So there's also an explanation where you can find the software. It's also on our web page. It's quite a straightforward installation of the software. Let me quickly show you. I've already installed the software, and if I start it here, then it will just prompt and ask which sensor I'm using. In this case, I put in the 2x, the sensor 2x, and then I will just start OK. And you can start run and play with different resolution and stuff like that. And here you will see the temperature and the humidity. And what I'm doing now is basically breathing onto the sensor, and you will immediately see that the humidity will rise and the temperature will rise, and it's quite a quick way to get a first grip on our sensors and play with it in relevant and different scenarios. So coming back to the presentation, so this is the live demo. And yeah, like I said, it's a very nice tool. If you have sort of an engineering prototype standing around, you can easily plug this into your whatever fridge or whatever you're developing and get a first-hand experience on it. So far for the technical part on these SHG3X sensors, please feel free to ask any question you want.
So far we don't have any questions, so we can continue.
Excellent. So now I will briefly talk about design guidance and handling instructions. As you might expect, the humidity sensor is always just as good as it's sensing its immediate surroundings. So it's very important to provide for a proper design of the sensor, and it should be it should be best coupled to the environment and not really to the whatever electronics of your device. So if you're building, for example, a smartphone, you will have several electronic devices in there, and it will heat up and stuff like that, and you don't really want to measure basically the temperature of your processor or stuff like that. So it's always important to have a good coupling to the outset or to the actual environment you want to measure, and to have a very strong decoupling to the inside, which is basically just the readout electronics or the processing power. In this case, you really want to maximize the opening of the housing, and you also want to keep this volume very minimal, so you're not having a huge response time before this outer environment will be completely in equilibrium with the inner, or vice versa. And you also want to prevent that there is a lot of crosstalk here from the housing to the actual sensing environment. So this basically needs to be sealed very well against humidity, for example. And the temperature performance also benefits if there is not a huge thermal conduction. So if you mount this on a metallic substrate, it's very critical to reduce the thermal conductivity towards the sensor. We will have, this is what I've already said. We have for the SMD assembly processing guidelines, which are hosted on our website. So the sensor itself is reflow soldering able to go through several reflow soldering processes. There might be the task to rehydrate the sensor, because if you heat it up for too long, the humidity gel or the polymer will dehydrate, and this needs rehydration. We also want to avoid high exposure to chemicals, and there are different chemicals which are contaminating the sensor. We have a list on our website where you need to take care that there's no high concentration chemicals going to the sensor directly. So I just put this as a link or a reminder. We have handling instructions on our web page, and there's more details to find there. So finally, what's really important to do or to not do with the sensor? It's really important to take some effort to make a proper design of the sensor, because otherwise the sensor can have a very fast response time and can have very quick accurate measurement values, or can provide it. But if it's not really talking to the environment, then this is not really useful to you as a customer. So the design is very critical, and we need to put a certain awareness to the processing guidelines so that we are not contaminating our sensor. And like I've already said, we have several handling instruction and documents on our website to detail or to discuss this topic in more detail. So finally, I would like to talk about a few application examples where we've already used the sensor successfully with customers, and they're having a good, really good value for what they're measuring there. So one not a daily example is building monitoring. So where company, it's basically an Austrian company, they've developed such a fit box where there are two temperature sensors which are deployed once you have your house, the raw structure is built. Then you want to put in your carpet or your wooden floor and stuff like that, and then it's very critical to wait the right amount of time to have the concrete dried out enough, because otherwise you will have still high humidity in the concrete, and once you put the wooden floor or the carpet on it, then you experience a huge damage there. So what these guys are doing, they put the fit box there and log the temperature and the humidity, and can accurately determine the humidity value, for example, before they start putting on the wooden floor, and also they can monitor it afterwards for a certain amount of time to better deal with customer complaints. So there also might be the case that the customer is just cleaning the wooden floor with whatever, like 10 liters of water, then and then there's a damage coming up. So then if it's a freshly built house, then there might be the discussion coming up if this was or if the customer is not mentioning this, then the house builder would be kept suitable for or liable for this incident, because they will complain that the concrete was not dry and they put in the floor too soon and stuff like that. So this is an excellent solution to actually provide a good building history, and to also make it trackable for the user, for example, for the house owner, so that everything's going right. And another example is, for example, is in this case the Nest company, which was just recently purchased by Google with I think over $3 billion. They are building smart home devices. That means they have a smart thermostat which is talking, or which you can control with your smartphone via an app, and this will allow you to make a smart home control. And we have developed together with Nest, or we have put our design in expectations and our sensor know-how into this thermostat, and this way this is a very interesting application to promote your home to a safer or in first case to a more energy efficient way, and in the second case, Nest is also now producing fire alarms or smoke detectors, and there's also the certain need for humidity sensing there, because you don't really want to detect with your fire alarm that you are now having a shower. And that was basically the main problem for many of those fire alarm manufacturers, that if they have their fire alarm somewhere in the house, that there will be a false alarm during showering or when you're boiling your noodles or you're cooking rice or whatever. And with this additional information, you can quite highly discriminate between a real fire and smoke threat, or between just having a hot shower or boiling some stuff in the kitchen. And this is also some advancement towards safer home, because lots of people just killed the fire alarm because it was always going off when they were showering, and then they wouldn't put it on with batteries, so they was just sitting around without any use. Finally, let me address the resources that we will provide. But before I will go into this slide, Miriam, are there any questions so far?
So far, no.
Okay.
Okay.
So let me just come to an end with my talk. We will provide several resources on our web page. It's www.sensirion.com, where we have a download center and also product science, where there are the latest data sheets and the instruction guidelines and handling guidelines for using the sensor efficiently, and you will find the most actual data there on the web page. Finally, I would like to summarize the main points of my talk, which is that humidity is a very daily experience for every one of us, and it's usually not that easily accessible like temperature. Temperature feeling is quite good. Humidity feeling is not that accurate in humans as the temperature sense. So we have developed a large variety of humidity and temperature sensors, and since we are doing this for quite some time now, we have a comprehensive and innovative product portfolio developed. So we will have all that the learning curves are implemented into our newest sensor generation, and we are quite proud that we are leading the quality and reliability, performance values which are currently on the market. We have a very small but also very energy efficient package and sensor devices now, and we will also provide, for example, technical support in the case of design in or expertise that we are willing to share from previous projects on how to get the best out of the sensor. It's very important to track humidity and temperature if you want to increase your energy efficiency. This is also, for example, the case in automobiles, where few customers are now trying to sense or are sensing the humidity in the air that is brought to the engine to increase the combustion performance. And it's very important if you want to guarantee certain processes and quality values. For example, if you're shipping foods or fresh like vegetables, and it's also very humidity on temperature is a very daily are very daily values if you want to have a comfortable environment in your office or at your car, in your car or at home. So far this is what I wanted to share with you. I would like to thank you for your attention, and I'm still here to answer questions if you have any.
Okay, we have some questions. So first question is, I2C addressing. I have working with SHT7 series. All of them have the same address. Does SHT3 series have changeable addresses?
You mean the I2C address?
Yes.
Yes. No, the sensor, the address will be kept the same.
Okay. The next question is building monitoring. How big has been air gap for sensor at the material interfaces?
That is a good question. I honestly don't know the exact value, but I believe if you can look up more details on the web page of this Austrian company, and what I would also suggest is to keep it as small as possible, and at the same time allow for some movement of the floor. But I'm not an expert in this, so please have a look into the details on the web page of the Austrian company who is doing that.
Okay, thank you. Next question is there any issue if the sensor is used at environment where condensation occurs sometimes?
No, this is not an issue. So there will be droplets forming on the sensor, but once the droplets are gone again, the sensor will I mean, if there's a droplet on the sensor, then for the sensor the humidity is 100%. That's what's the case. But if you now reduce the humidity, the relative humidity of the air, and there's still a droplet on the sensor, then the sensor will still measure 100% relative humidity. But as soon as the droplet is evaporated, then the sensor will accurately measure again the relative humidity of the surrounding air.
Okay, we got some more questions. What about if the sensor being wet, like totally by water, after drying the sensor will be okay again?
Yes.
Okay. And second, now I cannot see any other questions so far.
Let me quickly come back to the last question about the sensor being completely immersed into water. This is something where we explicitly also developed that membrane option with the Gore-Tex membrane. So if you want to still have dip your sensor into a glass of water and then you put it out, and then you want to quickly again measure the relative humidity of your room, for example, then it would make sense. And then it is very important also to keep the droplets away from the polymer. And this is what we do with the membrane option. But if you don't have the membrane on it, then to really accurately measure the environmental relative humidity, you need to wait until the water droplets on the polymer are completely evaporated again. But it's not a problem for the sensor.
Okay, so thank you, Max, for your answer. So far, I cannot see any other questions. So anyway, if there is any further question also after this webinar, just feel free to ask. And meanwhile, I received some more questions. How connect cables to sensor? Is there any socket?
You're talking about now the sensors which are provided in the evaluation kit?
Hold on. Please, Mr. Richard, can you specify your question? So we will wait for more information about this question. No, in application.
In application, what we do is if you order a sensor with us, then it will be just the chip scale package sensor. And for evaluation purposes, we have those sensors sitting on a PCB with a pin connector and on a flex PCB. This is the way that we could also provide evaluation samples, for example. But our sensors are just delivered as a DFN package, and the customer has to decide themselves how they want to connect the sensor. But there is one option which has a pin connector, but this is not the standard option. But you can order this as a pin connector. That's the case.
Okay, thank you for your answer. Now I cannot see any further question, but as I mentioned before, if there is any question regarding this presentation, feel free to contact us, and we will answer this question. I would also like Max, you for your presentation. Would like to thank you for the presentation. And also, I would like to thanks to all our attendees for attention. As was mentioned during the presentation, for all participants, there will be available special offer for evaluation kit AKH5 for special price, and this offer will be sent to you tomorrow. And also, for all the participants, there will be a SHT31 sensor with reference design. So hope every participant will receive this sensor as a present for this webinar. Is there any further information from you, Max, you would like to share with our attendees?
Yeah, the reference design that you just mentioned is basically what I call the gadget, this Bluetooth gadget, and yeah, I really appreciate it to be able to talk to you here on this occasion, and I would like to thank you, Miriama, for hosting us here and promoting our sensors. Thank you very much, and from my side, there are no further points, but feel free to ask questions if there are any questions, and send them to Miriama, and I will try to help you with that.
Okay, thank you one more time for the presentation, and thank you for all for your attention. Also, the whole webinar, the presentation will be available at our web pages next week, so you can see it at our web page. And also, we are preparing some further webinars in November, so we are looking forward to meet you at our further webinar. Thank you very much, and have a nice day.
Thank you. Have a nice day too.